This is a short tutorial on 3 tools often associated with continuous integration and continuous delivery: Docker, Jenkins, and Rancher. I'm Miriam Heller, and I recently learned about these tools as a graduate student at the Georgia Institute of Technology. I was using them in a project with my teammates in a course on health informatics. I really enjoyed them and I wanted to share. I'll first set the stage for the use of these tools by describing how computing has changed over the course of the last 20 years. Then I'll describe each tool individually and what it's used for, how the tools are used together, and how I use the tools with my team in this course. Computing has changed radically. Computing architectures at the turn of the century were monolithic. They were essentially self-contained, with program components that were tightly interconnected and interdependent. Today, computing is often provided as a service composed of loosely coupled modular microservices. This architecture exploits abstraction, facilitates reusability, and enables continuous maintenance of smaller bugs and updates as opposed to the semi-annual and annual large-scale version releases of the past. Computation and storage have also been modularized. The outcome is that large servers have been replaced by clusters of small servers and devices. In fact, computing devices and storage are less likely to be physically located in the company using them. Instead, they're shared in the cloud with optimized utilization. Abstraction has also led to the shift from platform-specific computing and storage to virtualization and portability. The 3 tools discussed in this talk all facilitate virtualization, portability, version and dependency control, continuous integration, and frequent redeployment. The first tool that we'll be discussing is Docker. Docker is an open source, lightweight virtual machine service built on a host operating system kernel, typically Linux, sometimes Windows. Docker relies on 3 objects to assemble applications. The first object is the image, which is an executable package including the code, a runtime, libraries, environment variables, and configuration files. Basically, the code and all of the dependencies necessary to create an environment. The second object is the container, and a container is somewhat of an abstract concept. It is an instance of a running image. One can think of the image as being on disk and the container being in flight. Third are services that offer scaling across and coordination across multiple containers. The Docker also offers a registry and Git-like capabilities. Users can share by storing within a repository their images, pull and push them. So what is Docker used for? There are 5 key ways that Docker has become the leading industry container. It now holds about 70% of market share in the container market. Docker can minimize or can eliminate variations in package versions and dependencies among computing environments during the development and release cycles. Docker can offer 100% virtual consistency throughout the development environments, and so can reduce costs of updates, yet it can still offer the flexibility of building, testing, and releasing images that can be deployed across multiple environments. The portability afforded by Docker's virtualization from actual infrastructure has extended to the cloud. As of 2019, all major players in cloud computing have embraced Docker, including Amazon Web Services and Google Compute Platform. Docker containers, because they work like Git repositories in terms of version control, can also help address issues or incompatibilities that arise due to the introduction of a new component or an upgrade. Basically, these situations can be dealt with quickly and easily by simply rolling back to a previous version, testing and fixing, and downtime can even be avoided. Replication and redundancy are also easily achieved. Docker enables isolation of applications and resources so that when a specific or a special resource is needed by a particular application or stack, or if a specific configuration is needed, Docker can address each of these issues independently of one another. This capability in isolation also has implications for security. Docker containers are completely isolated from each other so that if there are special security requirements for a particular container custom specified, or if security issues arise in a specific container, each of those can be addressed independently of one another. Now we're going to turn our attention to Jenkins and what Jenkins is used for. At the simplest level, Jenkins is an open source task manager. The activities that it coordinates are theoretically entirely arbitrary, but in practice, of course, Jenkins is most often used to implement the continuous integration, continuous delivery pipelines, like the virtual conveyor belts for software development teams. It works with any programming language and for multiple platforms, including Windows, Linux, and Mac OS. It has an extensible plugin-based architecture that enables customized builds, test, deployment, automation, and workloads. And because everything is automated, it reduces build cycle inefficiencies where individuals are actually going through these processes. It allows automation of unit testing and integration testing, for example, and it automatically monitors team member commits as well. So it interacts with, for instance, GitHub. Finally, we're going to address the tool Rancher and what it's used for. It's a management tool that schedules and orchestrates container farms or clusters, which are, again, combinations of multiple servers running container operating environments like Kubernetes or Docker Swarm. It offers container as a service in that way. It can monitor the health and any needs there are for upgrades, and it can effectuate load balancing across any of these containers, either within a cluster or across clusters. And it provides for security, SSL and TLS certification, and it can terminate your process and such if you have let things expire. I'm going to very briefly turn to an example of Jenkins code, because this will be the first time we're looking at how we use the three tools together, but in a more tangible way. So this is a Jenkins file, the Jenkins file. We initially had written things up to do the builds within the Jenkins file so that in a test format, and this is basically explaining how one has certain restrictions on what you can put into the repository, the Docker repository. Here we have the actual build and push of the containers, and we start with the Postgres database container, because if you recall, that had to be started first. And this is basically code that's deploying these in the order in which they need to be deployed. So next we do the backend service, and we end with the Medrec front end. Once those are up, we do our last specification, and this is an example of Rancher not doing very much, but doing something important, which is monitoring how we are deploying the containers and giving them a maximum timeout of 180 seconds, 3 minutes, at which point we would begin to get failures. But in this way, this is all automated and there is not a human intervention. In order to answer the questions that I was supposed to answer, I would like to say how Docker, Jenkins, and Rancher are used together. Recall that HDAP was our server environment, and in that example we used Jenkins to assemble Docker container images as software is built, and the images were then executed, as we saw, in a Rancher orchestrated clusters, running Kubernetes as the cluster operating system. The last thing I'd like to say is, or the second to the last, is basically we added the Docker file and Jenkins file instances into our GitHub repository, and those provided the recipes needed to allow Jenkins to assemble the Docker images and then inject them into the Rancher-driven container execution farm. The Georgia Tech instance of GitHub is where our software repository lives, and Jenkins, as a continuous integration tool, is sort of event-driven, and it is perpetually watching whether there are changes. So once it notices that there's a change, it triggers a build, test, and deployment pipeline based on the Jenkins file and the Docker file recipes that are in the repositories. I hope you found this interesting, but I'm going to end with some more contextualization. We learned about 3 tools, one for building using Docker containers, and we saw a little bit about how we would actually deploy them manually. And we learned a bit about Jenkins, which is the pipeline to coordinate or to initiate each of the tasks that a human normally would do, and thereby reduce errors that may be introduced, and certainly reduce the time of the transitions. But in fact, these are 3 tools among many in the very complicated but rich offerings in terms of continuous integration, continuous deployment, delivery and deployment, and ways in which we can, the variety of tools we have to virtualize our processes and the variety of platforms. I have shown you here that in terms of platforms, we have over to the to the right in the second long column, we see Docker and we see Rancher. Along the top horizontal line, we have our GitHub and Jenkins processes. Learning these tools is very similar to learning a programming language. If you master a programming language, it's usually you will be able to learn other similar programming languages much more quickly, and that is the case with these. So I intend to be learning these 3 tools in much greater detail, and I hope you've enjoyed this presentation, and I would like to thank you very much for listening. I've included at the very end of the presentation 3 of the references that I drew from. Again, thank you for listening.